Hi there, this is just basically a group of examples, in particular indefinite integral examples. So let's just start off real quick. We'll have the integral of 3x plus 2 squared. And I know what you're thinking, well, what about the chain rule? And you're absolutely right. You know, we can't deal with that just yet, so what we're going to have to do is we're going to have to actually algebraically break this down and then reassess the situation. So what I'm doing is just breaking it down. X squared plus 12x plus 4 dx. All dx, right? And that's that whole value. So now that we broke it down, essentially you just take it one bite at a time. And I really shouldn't break it down this much, but I'm going to do it anyway. X 2 plus 1 all over 2 plus 1 plus 12 x 1 plus 1 all over 1 plus 1 plus 4x plus c. Okay? So now the actual solution will equal 9 divided by 3, that's just 3x to the third, plus 6x squared, plus 4x, plus c. And that is the integral of that. And that is the integral. You don't have an answer for c, we don't have any conditions. So c just stays there. Alright, let's move on. What if we had the integral of x plus 8x squared divided by x cubed? Yeah, there you go. Once again, we cannot deal with quotients. So algebraically work it out so that we can simplify it a little bit. X to the negative 2 plus 8x to the negative 1. Okay, well, when you work that out and you solve for that, first of all, just do the same rule, the power rule for the first one, right? So what you're going to get is x to the negative 2 plus 1 all over negative 2 plus 1 plus, and then you have your multiplier 8, and what is the integral of 1 over x? Well, that one's ln of x plus c. So now that's right, this is our solution right here. You have your essentially negative 1 over x plus 8 ln of x plus c. Very handy. Let's keep going. Keep going with some more examples. Integral of, let's say 10 over x dx. Well, let's just pull out that 10x because that's just like multiplying by a constant, so I don't like constants typically being inside my integrals. So that's the same thing as integral over 1 over the rad x, which is actually the same thing as the integral of x to the negative 1/2, which, when you do it, what you're going to get is x to the negative 1/2 plus 1, ignore that plus, negative 1/2 plus 1. So, what we're getting is rad 10 x to the 1/2 and then times 2, right? So you're actually going to divide by 1/2, which is the same thing as saying times 2. So let me actually just kind of give you a quick ending solution. It's going to be rad 10x. I just tossed that square root of x into that 10x. So, yes, that could simplify out a little bit better, but, you know, I kind of like it like this. I like this solution. So, alright, how about, this one is kind of cool. X to the multiplied by rad x plus third rad x plus the power of 1/5, right? So if you multiply that all out, that's actually the same thing as when you multiply this x, you kind of distribute it through. This is the same thing as x 3/2 plus x 4/3 plus x 5/4. Simple. Then you just break it down like we've always been doing. Equals 3/2 x 3/2 plus 1, all this plus 1 plus x 4/3 plus 1 all over 4/3 plus 1 plus x 5/4 plus 1 all over 5/4 plus 1. So yeah, really this all simplifies out. It gets pretty simple after a while. Not. X to the 5/2 plus 3/4 x to the 7/3 plus 2/9 x 9 to the 4th. Very good, very snazzy. And that is your solution. Now what are we forgetting? We're forgetting our constant. Can't forget the constant. Never ever. Never ever. We have room down here for a quick one. Integral of e to the x plus secant squared x dx. Okay? Well, here to tell you that this is all pretty much just like chewing bubble gum. It's just rinse and repeat. All you gotta do is e to the x, and then you look it up and you say, oh, well, secant squared x, the integral of that just goes to 10x. Then you just got to remember to add your constant. So after a while, pretty much this whole topic, well, a good portion of this topic becomes essentially from tables. So while your teacher may require you to memorize things now, in the future you're going to be pretty much just looking up some things in tables later on. So get your foundation now, and don't worry if you forget things. It's very common. They're not easy to remember. So leave comments if you want more examples, and you guys have a good day.